raise your hand. I'll try to speak up, but my voice is going. I'll start by doing something that I've talked about climate change for over a decade, and I never did this until recently, but because I should have been doing it all along. And that is, on behalf of my generation, Dr. Webb's generation, apologizing to you guys. We have created, we and the generations before us, to some extent you too, but mostly our generation and the ones before us have created a problem that is, it is an immense problem. And our generations don't, ours and the ones that came before, don't appear to be willing to do a whole lot to fix it. And that leaves it up to you. I think one of the messages that will come across in today's talk is that the developing world also owes an apology, the developed world also owes an apology to the developing world, and in particular to Africa. And that I think will become clearer as we go through. Okay, there are going to be 5 parts, 5 things I'll address. First is what's been happening to climate on our planet, so past, the patterns and causes of recent and near past climate change, what the future holds. So what kind of climate change can we expect in the future? And the big lesson there is going to be, the big point is going to be, it depends on choices that we're making today and that we continue to make in the future, especially about where we get our energy. And then we'll talk about consequences for Africa. First of all, consequences for species other than humans, plants and animals in particular that inhabit the continent of Africa. And then we'll talk about what it's likely to mean for humans in Africa. And we'll finish by talking about solutions. And the good thing is that the solutions are ones that we have available to us today. We simply have to decide to use them. And I'll talk about one solution more than any other. Okay, so what's been happening on our planet? Since the turn of last century, since 1900, Earth has warmed about 0.8 degrees Celsius. If you want to convert it to Fahrenheit, that's about 1.5 degrees Fahrenheit. Doesn't sound like a lot, but it is. This is what the thermometer record looks like. Back in 1880 or so, we had enough thermometers over enough of the surface of the Earth to give an accurate average temperature of Earth. And if you look at this, what you can see is that there was a period of warming early last century, from roughly 1900 to about 1940. Then there was a period where Earth's temperature statistically did not change. Decreased a little bit, but that wasn't a real decrease, a statistically significant decrease. And then starting about 1975, we entered our current and continuing, ongoing period of more rapid warming. If we look at the warmest years in history, all of them except 1998 are in this millennium. 1998 has the asterisk next to it here and also up here. One thing to be aware of. I'll talk about skeptics' arguments a little bit because there's a tremendous amount of misinformation that every American is exposed to about climate change. One of them is that, okay, Earth used to be warming, but it stopped warming. And that's an argument that only works if you use 1998, that asterisk year, as your starting point. 1998 was the last super El Nino year on our planet. We had 2 last century. That was the bigger of the 2. In a super El Nino year, Earth is a lot warmer than it normally is. So if you use that as your starting point, then there hasn't been any increase since 1998. If you use 97 or 99 as your starting point, there has been. Earth is continuing to move. So beware of skeptics' arguments that say the Earth has stopped warming. It hasn't stopped warming. And in fact, it's warming very fast. And one of the things that matters to all species is not just the magnitude of change, but how fast the change happens. So the rate of change is really important. And it turns out that we're warming now 10 to 20 times faster than we have in at least 800,000 years. 800,000 years is as long as our ice core record is. So we have good records of actual temperature on Earth for 800,000 years out of the Antarctic ice cores. And it's probably, very likely we're warming faster than we have in 55 million years. So it's really an unprecedented trend. I think the best way to see what's been happening to our planet is to watch a roughly 30-second video. This is NASA's creation, and the colors represent for any place on the planet in the year shown at the bottom of the slide. These will go by one, So in whatever year is currently showing what the temperature of that place was relative to the average temperature in the same place, basically middle of last century, between 1950 and 1980. So 1950 and 1980 average is the baseline. If, for instance, a place like Brazil is, well, let's take South Africa. South Africa in 1884 is blue. That means that South Africa in 1884 was cooler than South Africa was on average from 1950 to 1980. Okay, so cool colors and warm colors pretty much speak for themselves. Okay, so let's see what's been happening to our planet. And now we enter that first slower period of warming, lasts about 40 years. Okay. And now we enter about a 35-year period where Earth's temperature goes up and down but doesn't change significantly. Now we're into the current faster warming. Okay, so that's what has been happening to our planet. That's not a hypothesis or conjecture. That's thermometer data. Right? So Earth is clearly warming. One of the questions that I think everybody needs to know the answer to is, are the skeptics right that this could be due to natural variation? And the answer is no. Natural variation just can't explain this warming that we're experiencing. One of the things I would ask somebody if they say, oh, it's just natural cycles or natural variation, I would ask them what's causing it. And there are only, they probably can't tell you, but there are only two things that can appreciably change Earth's temperature on the order of a century or 2 centuries. One is that if we get more energy, if the sun was more active and we were getting more energy from the sun, then Earth would warm. If the sun became less active, we would cool. So a more active sun could cause warming. The other thing that can have a big effect on Earth's climate is volcanic activity. There have to be a lot of it. And in fact, we can discount that because volcanoes cool the planet. They don't warm it. That ash that goes up blocks out sunlight and cools the planet. So we can eliminate that as a cause. And when people argue that it's natural variation, what they're really saying is we've been getting more energy from the sun. You may not know that that's what they're saying, but that's what they're saying. Have we been? Well, it turns out that in this period of most rapid warming, since about 1975, Earth's actually been getting less energy from the sun. The blue line is temperature since 1885. We saw that before in the earlier graph. The red line is energy arriving from the sun, and that's our current and most rapid period of warming. So there is no basis for the argument that this is natural. It's us. So one of the other things that you hear sometimes is that the scientists themselves are arguing about whether it's humans or natural variation. So let's ask, is there any debate among scientists about whether humans are the primary cause of warming? One way to do this, there are a lot of ways. They all show the same thing. But one way to do it is to ask, how many scientific societies, I mean national, international societies of very high reputation scientists have in their society statement something like this. Most of the global warming in recent decades can be attributed to human activities. So what scientific, if any, scientific organizations endorse this statement? If we look within the U.S., the first one I would ask about is the National Academy of Sciences. That's the top scientists in the U.S., and arguably this is by far, the best scientific organization that's existed in the history of humanity. And they've had this as a statement of theirs for 20 years. And if we look at others, the American Medical Association has this as their statement. They have no vested interest in it. Climate change is not a source of funding, which is one of the false accusations that's often made about scientists, that climate change is a hoax so that scientists can get funding. It's an absurd accusation, but it couldn't be applied to people who are members of the American Medical Association. We don't do research on it. Why are they concerned about it? Because we're likely to be affected. Human health is likely to be affected. Any other organizations within the U.S.? You can see the number here that span a variety of disciplines. Here are some more. All kinds of organizations, all very high quality organizations, a few more. If we look at Europe, every European country that has a scientific society, that society has endorsed this statement. If we look at other countries, there is a variety here. The African Academy of Sciences, the Academy of Sciences of South Africa. And I'd actually point out that one right at the top. China is indisputably the major CO2 emitter. And if in their society, if their scientific group can state that humans are causing, which means China more than any other humans are causing climate change, the evidence has to be pretty strong. Okay, but if there's a lot of debate, there could be an equal number of scientific organizations that hold a dissenting opinion. So let's see who does. Okay, that's the entire list as of 2007. As of 2008, there isn't a scientific society that holds a dissenting opinion. So there is no debate among the scientific community. Just to recap, current warming in two major ways is very different from warming that our planet has experienced in at least 800,000 years, probably 55 million years. It's a lot faster, 10 to 20 times faster, and it's happening while the thing that previously caused climate to change is changing in the wrong direction. Solar input is decreasing. Okay, so that leads us to best estimate that 95% or more of current warming is because of human activities. What activities? Mostly the burning of fossil fuels and emission of greenhouse gases. That's about 80% of our effect. About 20% of our effect is cutting down forests. And Africa is a place where forest deforestation is happening very rapidly. When you take down a forest, two things, it has two consequences. One is you take away a carbon sponge. Trees were pulling out carbon from the air, carbon dioxide. They're not doing that anymore because they can't photosynthesize if they're not there. And the other thing is that the wood, which is mostly carbon, usually gets burned or decomposes and the carbon dioxide goes into the atmosphere. Okay, if we looked, and Dr. Webb alluded to this earlier, we'll see this theme come out several times. That's a map of countries' actual proportion to their actual size. If we drew them proportional to their national CO2 emissions, it looks very, very different, and Africa almost disappears. So what that really says is Africa is not causing the problem, has not caused the problem. What is the future likely to hold? And I want to stress, because it can be pretty, it can cause a lot of anxiety, that we have choices available to us. The future is not cast in stone. We have to make the right choices, but if we do, many of the things many of the realities that we're currently heading towards don't have to actually happen. So what does the future hold? It depends on choices we're making today and that we make in the near future. Okay, do you remember her mantra? People know who this is?
Is that the girl from... I was the girl from Terminator.
You're right. It's Sarah Connor from Terminator. And like, she's trying to prevent a horrible future from happening. Right? And what does she keep repeating to herself? No fate but what we make. That's her mantra. And that should be our mantra too. We have the possibility of making the future an awful lot better than the one we're heading towards right now. Okay. But if we remain on our current course, there's no question that future climate change will be severe. Depending on basically where we get our energy from. If we continue to get it from fossil fuels, if we get most of it from alternate energy sources or some mix in between, Earth is likely to warm between 2 and 5 degrees Celsius by the end of the century. Here we have year across the x-axis, so 2100 end of century is all the way on the right, and the amount of warming on the left. The black line is what's already happened. And then let's talk about a few of these other lines. The blue line is what would happen if we switch over fairly aggressively, not as aggressively as we could, or I would say should, but if we switch over fairly aggressively to alternate energy sources, we can probably keep warming to about 2 degrees. And that actually is the scientific community's recommendation, that that's our target. I think we should be lower than that. What's usually referred to as the business as usual scenario gets us to about 4 degrees warmer by the end of the century. But it's an inaccurate title. That's not really what we're doing. What we're really doing right now gets us to about 5 degrees. So our actual emissions trajectory gets us to about 5 degrees. Okay, so think 9 degrees Fahrenheit. Would that matter? Would a 5 degree C temperature rise matter? Doesn't sound like a lot, right? It changes more than that in a day in Kalamazoo. Well, we know what Earth was like when it was 5 degrees cooler. Right. This room was under about 3/4 of a mile of ice. So that change may sound small, but it's absolutely enormous. What would it be like if it was 5 degrees warmer? We don't know. Hasn't been there in 55 million years.
55 million years?
55 million years. Since what's called the Paleocene, Eocene thermal maximum. What will this mean for Africa? Well, Africa is predicted to warm to different degrees depending on where on the continent. South Africa and the Northwest are predicted to warm the most, but on average, any given place in Africa is predicted to warm by about 3 to 5 degrees. Again, it depends on how much greenhouse gases we emit. One thing to keep in mind is that climate change isn't just temperature. A very important part of climate change is precipitation. And it's harder to predict than temperature change, but consensus predictions are that in green areas, precipitation will increase. In the brown or orange or reddish areas, precipitation will decrease quite strongly up here. And in the light-colored areas, not change very much. But if you think about what you need, if you were growing crops, what you would need to have happen with precipitation, if temperature was increasing quite a bit, you would need a big increase in precipitation to have the crops remain viable. So most of Africa is, the combination of temperature and precipitation change is not a favorable one. Okay, if we look at some of the more, I guess, worrisome components of climate change, they really are extreme events. One of the things that happens with climate change is extreme events become more extreme and more frequent, and it's extreme events that really do damage. So one kind of extreme event is heat that hasn't been experienced before. A recent paper in Science used a big ensemble of climate models to try to predict at mid-century and end of century for every place on the planet how likely it was that a summer would be hotter than any summer that place has experienced so far. So what's likely that Kalamazoo would have a summer mid-century that was hotter than the record hot summer in Kalamazoo today. This is the prediction for mid-century. It's 2040 to 2060, so spanning the middle of the century. And if we look at, let's focus on Africa, anything that is yellow, any place that's yellow is predicted to have half to 2/3 of its summers be hotter than any that place has experienced so far. Orange is 70 to 90%, and red is 90 to 100%. So there's quite a bit of Africa that's predicted to have unprecedented heat during the summer. Let's say it averages about 50 to 70% in mid-century. What about end of century? At end of century, most of the continent is predicted to have almost every summer be hotter than any that has been experienced so far. What do you do if that happens? What do you do about growing crops? What do you do about keeping your houses cool and so on? But remember, this is the trajectory. This isn't actually even the trajectory line. This is a little bit less warming than the current trajectory. But we don't have to let this happen. When you have reduced precipitation or even stable precipitation and much higher temperatures, you get droughts, especially if you have long periods without any precipitation. And one of the most Well, actually, quite honestly, this is the scariest thing that I have come across in thousands and thousands of papers that I have read. And it's about the frequency of drought, the severity of drought. The first thing to do is just get in your mind which colors you want to look at. So these colors from orange through fuchsia, I'm not sure what it is, correspond to the current recognized 5 categories of drought. From mild drought through exceptional drought. Exceptional drought is called exceptional because it's a very, very rare event, or has been in the past. So those are the colors you want to keep an eye out for. Here's Earth in the 1950s. A pretty well hydrated planet, very little drought. The next one will be Earth in the decade that just happened. It actually doesn't include the drought that we've been experiencing in the United States. Right? Texas and Oklahoma had really bad drought in 2011, 2012. It moved up into the breadbasket. Now it's moved down to the southwest. So this next one doesn't include our record-setting drought. That's what's happened already around the planet. And the prediction, not for end of century, just for the 2060s.
And Dave, didn't Michigan lose like half of its agricultural product?
Michigan last year, this year was a good year, but last year we lost about 50% of the yield of many of our cereal grains. And we lost about 90% of our yield of food crops. But that was because we had a very warm spring and then a freeze. So the flowers had come out, the freeze took them all away, and you can't have fruit if you don't have flowers. But that's a world that has very, very substantial challenges for humans, not just in that. Okay, but remember, we don't have to let that happen. We have options. We just have to exercise the options. What is this likely to mean for plants and animals in Africa? I'll just summarize a few large-scale studies. First one looked at over 5,000 plants in, sub-Saharan Africa. And you can read the top that high losses, fairly high extinction rates are predicted even with what's called full dispersal. Full dispersal means if there's suitable habitat anywhere, that species can get to it and stay alive. So it's unrealistically optimistic. If there was suitable habitat on the moon, it could get to it and survive. So this is the most optimistic kind of scenario will lead to the most optimistic prediction. It's quite a wide variety of plants, and the bottom line is that 40% of them are predicted to go extinct by 2085. And 80 to 95% of them, including those 40%, are predicted to experience range reduction, so decreases in population. So basically predicted to be climate losers. But 40% are predicted to be ultimate climate losers to extinct. What about mammals? Quite a comprehensive study was done fairly recently of 275 large mammals in Africa, and most of them are predicted to be adversely affected. Of the 275 species, 20% are predicted to be extinct through climate change by 2080, even if we grant them an unrealistically high dispersal capability. So even with full dispersal. Strangely, well, actually one of those is predicted to be a climate change. It's the one I would have guessed last. The areas, it's got high populations in the areas that are predicted to see big increases in precipitation. And if we say, no, we aren't going to assume full dispersal, we're going to assume the opposite, that they can't move. It's unrealistically pessimistic. But with that assumption, then the extinction rate doubles to 40%. Where are African mammals likely to have the toughest time? Two areas, Congo Basin and Kalahari. South Africa and the Kalahari region is one that shows up again and again as being particularly vulnerable. There was a very good study done recently of every single bird species on the planet that lives in the mountains. you live in mountains, you're referred to as a montane species. It turns out that there are 1,009 mountain living bird species on Earth. Not all are in Africa, of course, and every single one of the 1,009 is predicted to lose population, and a number of them are predicted to go extinct. So montane bird species, there isn't a single climate winner predicted. In Africa, 40% of Africa's mountain living bird species are predicted to lose at least half of their range, so decrease by at least 50% is the inference. And like I said, this is for 1,009 bird species. The best prediction is that a species loses 13% of its suitable habitat. Okay, so they're all climate losers. One thing that's a little bit harder to understand or harder to explain is the concept of disappearing climates. It's actually fairly straightforward. You are predicted to experience a disappearing climate if the climate that you currently inhabit at the end of the century is not predicted to be anywhere within 500 kilometers of you. And the idea is 500 kilometers is probably farther than most species can disperse. So if your habitat, if your climate is that farther than that away, you experience a disappearance of your climate. So it turns out that the pattern of predicted disappearing climates, this is with a 3.5 degree warming, not even a 5 degree warming, is pretty clearly that disappearing climates are much more likely for tropical species, including African species. Red means a high probability of finding that your current climate isn't within 500 kilometers of where you are today. And that means widespread challenges, right, for not just birds, not just mammals, all kinds of species. Okay, what about human health? First of all, it's important to know that human health is already being affected by climate change. The World Health Organization estimates that climate change already causes premature death of at least 150,000 people each year. Some of their estimates are as high as 300,000 people per year. And you would not be surprised to find that that mortality is not evenly spread across all human populations. If you look at where the mortality is highest, it's exactly what I think you would have predicted. Current effects of climate change on human health are concentrated in Africa. So let's ask, how can, yes?
What kind of deaths are occurring from?
The majority are exacerbation of either cardiovascular or respiratory conditions. So it's not healthy people that all of a sudden are dying. It's people who are ill but could have survived a less rigorous challenge than they have to now with climate change. So what I want to do is talk very briefly about 4 different ways that climate change can affect human health, not just in Africa, but we'll talk about it with respect to Africa. One is increased heat stress. Another is change in either the frequency or severity of diseases. And you guys can probably figure out which disease we'll talk about. Another is changes in the rates of malnutrition. Crop failures, obviously droughts, crop failures lead to malnutrition. And the last one, which is hard to quantify, but there have been a lot of attempts lately, is changes in basically armed conflict. If resources are becoming scarcer, then it becomes more likely that wars will happen. Okay, so heat waves are likely to become more intense in Africa, just like everywhere. Most of the work, predicted future frequency, severity of heat waves, hasn't been done in Africa. Very, very little that's been done in Africa, so I can't say a whole lot about it. But these are the predicted maximum temperatures during heat waves. Darker red means hotter. And the bottom line is that depending again on what emission scenario we follow, the maximum heat during heat wave is likely to increase by 15 to 20 degrees. And It's not been quantified, but of course that's likely to lead to a lot more mortality.
So help me, 36 degrees Celsius is what temperature Fahrenheit? Anybody?
98. 36 degrees Celsius.
Someone's going to do the math. We've got a math.
9 times whatever Celsius
You'll
is.
work on it. Go ahead. We'll tell us later.
Research by 96. Before we talk about this, I just want to mention that much more rigorous studies have been done about changes in heat waves in the United States. And just as a reference point, Detroit historically has experienced a heat wave like the 1995 heat wave in Chicago, killed about 700 people in Chicago. Historically, Detroit has experienced that about once a century, so one in a century. If we allow Earth to warm by 4 degrees, then that sort of Chicago 1995 like heat wave is predicted to happen almost 2 times per summer in Detroit. Okay, how about effects of climate change on disease? And most of the attention has been focused on diseases that are transmitted by a vector, and that vector most of the time is mosquitoes. And chief among them is malaria, of course. So here is the current incidence of malaria worldwide. It's a tropical disease, has a bigger effect in Africa than any other place. And that's the chief vector transmitter of the disease, and the Anopheles mosquito. Just a little background on malaria. World Health Organization estimates a 250 million cases per year, most of which are not lethal, but 1 million of which are.
National Geographic said that half human beings who've ever lived on the planet Earth have died of malaria.
Wow.
So malaria, that malaria kept the Europeans from getting into Africa for a couple hundred years. It was quinine from South America that let them get in, really. So malaria is serious stuff.
The average African child has, along with it, to continue the theme of it being a serious thing, 1.5 to 5.5 episodes of malaria fever each year. And every 32nd on our planet a child dies from malaria. And most are African children under the age of 5. How is climate change likely to affect incidence of malaria? For the most part, under most climate change scenarios, malaria increases. But the change and the magnitude of increase depends on what climate change scenario we're talking about. If we keep warming to about 2 degrees, which would cause about a 10% increase in rain over this whole region and about a 10% increase in summer and 10% decrease in winter rain, then that's the predicted pattern of change in malaria, where red means malaria gets more common and green means malaria gets less common. So there are actually places that are predicted to have decreases in malaria. If we allow Earth to warm by 4 degrees, that's a very different story. There are much larger increases over a much larger period. The good news about malaria is that there are ways to minimize its, or at least decrease its frequency. And those ways are generally referred to as adaptation. And really what it means is changes in behavior. So in the 1900s, that was the pattern of malaria where dark green means it's basically epidemic all the time. In 2007, there's a lot less malaria. And if we look at the change from 1900 to 2007, everywhere where we're able to estimate the change has been, there's been a decrease in malaria. Why? Because of nets, and to some extent because of pharmaceuticals. So malaria, we could counter the effect of climate change by increasing adaptation measures to some extent. Malnutrition, I'll just talk very briefly about this. First of all, as background, the UN FAO, Food and Agriculture Organization, estimates worldwide over 1 billion people hungry, and I think it comes again as no surprise that the frequency of hungry people is greater in Africa than any other continent. With many areas, the darker red is 35% of the population, 35% or more undernourished. And in fact, in most of the countries in Africa, Saharan or sub-Saharan, a fifth to a third of children under 5 are chronically malnourished. And unfortunately, climate change is predicted to decrease the agricultural productivity, decrease yields of a number of important crops throughout sub-Saharan Africa. Here's the scale where blue means a predicted increase in yields, red means a predicted decrease. And if we look at corn, sorghum, millet, and groundnuts, 4 important crops, there isn't any blue. All of these are predicted to decrease, remain the same, or decrease in all of sub-Saharan Africa. And actually, South Africa, Zimbabwe, turn out to be 2 of the countries predicted to be most affected. Lasting effect on human health is through conflict, increases in conflict. Very, very hard to predict. This is the hardest of the 4 to predict. But the predictions tend to be that conflict will increase. For instance, in this particular study, it's probably the most cited of the studies, civil wars in each of 6 regions are predicted to increase by between 5 and 10% by 2030. These are the different regions. And just to sort of set your eye here, 0, so these are predicted changes in conflict, and 0 is no change. Anything to the right of it is an increase, and we'll just put a blue line for the 0 mark in each of those. So in each of the 5 regions, civil wars are predicted to increase, and if we look overall at sub-Saharan Africa, the predicted increase is between 44 and 54% in the frequency of civil wars, 44% with a 2-degree warming, 54% with a 4-degree warming. So actually 2-degree warming is not, that's why I argue it's not a great target tissue for, still has quite a few consequences. And getting back to something that Dr. Webb mentioned earlier and came up earlier in this talk, it's clear that developed countries have caused the problem that developing countries experience most of the adverse effects, especially health effects. So if we look at countries proportional to all of the CO2 that they emitted between 1950 and 2002, that's what the countries look like. The United States emitted, even though China is emitting more now, cumulatively we have emitted the most. What do you think and look at Africa, it's almost, again, South Africa, you can see, but most of the other African countries are just teeny. What do you think it would look like if we look at countries proportional to health effects of climate change? So if we look at health-related effects. So they're not just scientific issues, but they're clearly ethical issues involving climate change as well. Okay, so we've talked about these, and now I want to explicitly talk about what can be done about it. That's not a future that we have to experience. We have solutions at hand. We just haven't decided to implement them yet. So to avoid these futures, or at least a lot of what we've just talked about, the only way to do that is to rapidly and substantially reduce greenhouse gas emissions. Energy conservation is a wonderful thing to do. Turning off the lights, turning down your thermostat in the winter, turning it up in the summer, insulating your house, driving a more fuel-efficient car. They're all wonderful things to do. But they're wonderful because they make us do less damage in the meantime. They don't change the eventual outcome. If that was all that we do, then what we're essentially doing is burning fossil fuels a little bit more slowly. Doesn't change the eventual outcome, just delays it a little bit. So conservation is good to minimize damage in the meantime, but to really change the future, what we have to do is get our energy from something that doesn't cause greenhouse gas emissions, or at least nowhere near as much. The scientific community has said what we should do is aim for 80% reduction in emissions by 2050 to avoid the worst of the things that we've talked about. And there's only one way we can do that, and that's to get energy elsewhere. Two leading technologies are solar and wind. We've had them for a long time. We just have to decide to use them more. One thing that I'll point out, I won't talk about wind except to say that all of the 9 countries on the planet that emit the most CO2, every single one of those countries could get at least 3 times and up to 180 times all of its electricity from wind if it wanted to. Wouldn't have to burn coal. So wind is a very, very viable alternate energy source. I'm going to talk a little bit about solar because I think that's more germane to Africa. No question that solar energy is our most plentiful energy source. In fact, more energy reaches Earth from the sun in an hour than everybody on the planet uses in a year. The problem is harnessing. But it's a tremendous resource that we just haven't really tapped into very much. We do to some extent. We tap into it. We can tap into it in a variety of ways. The ones that I think hold the most promise fall in the category of CSP, or concentrating solar power. And there are basically 2 ways you can do this. And we've been doing this one. We've been doing for 50 years. California's been doing this for 50 years. And that is put a bunch of mirrors around the tower. The mirrors bounce sunlight up onto the tower. So all these mirrors are bouncing sunlight up here. The tower is filled with usually a salt that can heat up to maybe 12 to 1400 degrees. So the sunlight just heats it up. And that then takes the place of coal or natural gas as your heat source. All you need is heat, and you use the heat just like a coal-fired power plant does. You use the heat to create steam, and steam drives a steam turbine that generates electricity. So this isn't a little electricity, a steam turbine electricity generating plant. The other is a slightly more modern version of the same thing, where instead of focusing light on a central tower, the mirrors are trough-shaped, they're parabolic-shaped, and they focus sunlight onto an oil that runs down this conduit here, and that oil can heat up to about 800 or 900 degrees, and that's used to make steam. Once you make steam, you can generate electricity. So the question is, are you getting your heat from burning coal or natural gas, or are you getting it from the sun? Why is this more relevant for Africa? Because Africa has the best place for gathering solar energy on the planet. And in fact, it's incredible how small a part of the Sahara Desert could actually provide all of the electricity that humans use today worldwide. This little square here, using either solar towers or parabolic troughs, today's technology, that amount of area could provide all the electricity that humans use. This amount could provide all that Europe uses. And you could use some of the heat to desalinate water. So concentrating solar power could also be used to greenify the desert. Have excess heat, excess energy, and basically a desalinization plan is you take salt water and evaporate it. The salts stay behind you, the water evaporates, you condense it, now you've got fresh water. So given that solar plants generate so much heat, that's basically what they do to generate electricity. And you could use some of that heat to turn, for instance, the north coast of Egypt from desert into agricultural area. So the real solution is we've got to get our energy elsewhere. And part of making that happen is sharing information with others. So now that you guys have heard some things, and Alan, if you want, if there's a course website, I'd be happy to post a PDF of this if anybody wants to look back at it. But you've gotten information that I think would be very useful to share with other people. So share it with others. That's part of the solution, is combating the misinformation that everybody in this country is exposed to. And ultimately what it boils down to is getting the people that make decisions on our behalf to make better decisions. We have to encourage policymakers to make smarter choices. We can't make the United States have a requirement to get 80% of our energy from alternate energy sources by 2050, but our representatives can. And so we have to, but they're not doing it right now. The people who are representing us have apparently no interest in doing this. And what we have to do is get the people that make decisions on our behalf, in whose hands the fate of the world rests, to make better decisions. And